Assalamualaikum, my name is Muhammad Al-Amin. This is video presentation for Group 2 in the case study analysis for cost plasticity and application. The case we get is extrusion. Before we move to another part, I would like to introduce my group members. This group have 4 members, which are Ahmad Fuzail, Muhammad Al-Amin, which is me, Albul Khairi, and Muhammad Al-Wash. In this introduction part, I will explain the background of extrusion process. Extrusion is a type of metal forming process which dies are used to change the shape of a metal piece through the application of external compressive force. This method can be used to build any type of complex structure. Extrusion can be broadly divided into two types, which is hot extrusion and cold extrusion. And both extrusion have subdivided into two types, which is direct extrusion and indirect extrusion. In hot extrusion process, the mold or billet is heated in recrystallization temperature, while the cold extrusion keeps the workpiece at a normal room temperature. We see at the indirect extrusion, the force applied by the ram and the direction of the extruded metal are on opposite side. On the other hand, direct extrusion happens when both the ram and the extruded metal point in the same direction.
Standard operating procedure of the process. The process of extrusion is a method of shaping the metal by forcing the metal through the die using the ram. The die gives the parameter of the product, which is important to be an exact specification. The die is made of H13 steel, which is heated to 500 degrees Celsius to ensure long lifespan of the die, and also it's polished before extrusion. The aluminum is used in this experiment. Different aluminum types could be used, but to ensure the aluminum can go through the die, it must be heated in the furnace before being carried to the conveyor belts. After the aluminum pellet is heated, it's positioned before the ram. The ram is using 15,000 tons of force to apply to the pellet in order to go through the die. The final step of extrusion is when the ram applies the 15,000 tons of force to the pellet, which is pushed through the die. This works by applying force to the pellet, which is being countered by the die. This results in increasing amount of shear force done from the friction. After being extruded, the material is then pulled out of the machine and then quenched to cool down. After quenching, the material is then cut to appropriate size, and then once it's totally cooled down to room temperature, the material is then applied by the adjusting machine, which helps any correction for twists that happens during the process.
Assalamualaikum. Next is the problem faced in the extrusion process. Problem faced in the extrusion process is more towards the defects that will occur at the final product of the extrusion process. Generally, there is three types of defects. First is center burst. Center burst is an internal crack at the center of the extruded process due to high die angle. As we can see at the below diagrams, when the die angle is increasing, the gap between the plasticity deformation area will increase. Hence, the center burst to occur will highly occur, and it will be more worse when there is a really high die angles. Secondly is the piping. Piping is a sink hole at the end of the billet or the extruded products. generally occur in the direct extrusion process, and more tendency or high tendency to occur when the process is a hot extrusion process. Since there's a hot extrusion process, the material will have oxidize and impurities in it. The third is the surface cracking. Surface cracking at the outer surface of the extruded materials or extruded products. This is due to the high friction between billet and the die of the machine, and also due to the high extrusion velocity of the process. As we can see at the below diagrams, there is a research by some researcher on the effect of the velocity in the product of the extruded extrusions. As you can see, the higher the velocity, the bigger or the even worse the surface cracking will occur. Okay. Other than these defects, problems, some problems that might occur is inconstant of expansion due to the inconstant force applied to the ram and wear out, which is caused from the friction between the die and the billet when the extrusion process is on. Thank you. Next is for the difficulty and the constraints. In terms of the constraints, we can divide it into three. First is variation, cost, and materials. In terms of variations, this process only can be done or only can produce one shape of cross-section area in a time, since the die or the process is a inline process, hence the instant process need to be finished before can be changed into another die of a cross-section area. Secondly is the cost. This process having a high setup cost, such as labor cost, since the process is a inline process for a product of the extruded for a extruded products. One extruded product needs time, so it will increase the labor hour of working and increase the labor cost to produce one product of extruded products. The third is materials. This process is not suitable or cannot be used for extruded thermoset plastics, since plastic is a brittle materials and need to run a hot extrusion process. Thermoset plastic is a material which will degradables its quality upon heated. Hence, this material cannot be used as a extruded process. In terms of difficulty, it is more toward the difficulty to control the process to have a good final products. One of parameter that need to be controlled in this process is the pressure applied from the ram or force applied to the ram. This parameter need to be obtained first to achieve two objectives. The first objective is to apply plasticity applications, since a materials to have a plasticity application on it, it need at least to reach the stress of the yield of the materials to occur the strain hardening and give the final product that not be in elastic region. The second is to avoid defect such surface cracking, since when the pressure is too high, the pressure it will cause the velocity of the ram increase and cause the surface cracking to occur. Thank you.
Next is the variation of extrusion force with ram travel in direct and indirect extrusion. From the figure, it shows the ram force as the metal is being extruded for the direct and indirect extrusion. From the figure, we can see the extrusion force increase steeply, which is when the metal billet is first compressed in the longitudinal direction and deformed plastically to the size of the container until it reach the peak force, or it can be also called maximum force or breakthrough force. As it reach the maximum, after it reach the maximum force, we can see the reduce in the reduce in the extrusion force, which it is because of the length of the metal billet reduced as it being extruded be, due to the reduce in the friction between the billet and the container. At the end, we can see the pressure or force rise up rapidly at the end of stroke in attempt for the billet to exit the die and leave a small discard in the container. In indirect extrusion, there is no relative motion between the billet and the sidewall container. Therefore, there is less friction between and less friction, which reduce the force needed to extrude the metal billet compared to the direct extrusion, which you can see from the figure. Next is the metal flow in extrusion. Figure A shows the flow pattern achieved at low friction, which can be seen in indirect extrusion or when the lubricant is effective. Figure B shows the pattern where we can see the formation of high shear area as the material flow into the die exit. It is because of the high friction at the billet chamber interface, where we can also see the develop of that metal zone. The billet surface may be extruded into the high shear zone, which lead to the flaws in the final product. In figure C, we can see the high shear zone extends further into the billet, where it is because of high container wall friction of the billet, or when the billet outer area were cooled in the chamber and the metal strength rise sharply with falling temperature. In hot working, the material near the container wall cools rapidly and hence increase in strength. Therefore, the material in the center region flows toward the die more easily than that of the outer regions, which result in the formation uh, of large dead metal zone and inhomogeneous flow, causing pipe or extrusion defect, which can be seen from the figure C.
Let's take a look at extrusion process in plasticity application. In current technology, metal are commonly extruded using hot extrusion, reduce force, eliminate cold working effect, and reduce anisotropy. The example of metal that use hot extrusion is steel, stainless steel, nickel-based alloy, and titanium. These metals have high yield strength and proximity to weld. In hot extrusion, we can see that indirect extrusion are more efficient than direct extrusion. In other hand, the cold extrusion is common for ductile metal and simpler shape. And the example of metal that used in cold extrusion is aluminium, magnesium, copper, lead, and alloy. These metals have low yield strength and low working temperature. And the example of cold extrusion is impact extrusion, and hydraulic extrusion. Next, we look the future technology in extrusion. The complexity and range of parts which can be produced by the extrusion process are large. Hence, the process takes the shortest amount of time compared to other metal forming process. Moreover, extrusion is a terrific way to work with brittle and ductile material. In addition, the mechanical properties developed by the extrusion process are very precise and improve the product life cycle. Besides, the extrusion process can be easily automated and the dies are simple and easy to make. Nevertheless, the time consumption of this process and the initial setup costs are also quite high. Next, the product's production is limited because only one type of cross-section can be manufactured at a time. So, for the future development, there should be an alternative way to reduce the time consumption and the initial setup cost of this extrusion process. Besides, the production needs to improve where there will be more product in one process. So that's all from us in this video presentation. Thank you for your attention. Thank you. Thank you for the attention even